Our next presenter, Dr. Sabine Hazan. She is a pioneer in the field of microbiome research, and her work is paving the way to help us better understand the implications of gut microbiome on mental health. Dr. Hazan is the founder and CEO of Malibu Specialty Center and Ventura Clinical Trials, where she conducts and oversees clinical trials for cutting-edge research on various medical issues. Dr. Hazan is a top clinical investigator for multiple pharmaceutical companies and also acts as a series of editor of Practical Gastroenterology on the Microbiome, a peer-reviewed journal that reaches over 18,000 gastroenterologists. So let us please welcome Dr. Hazan to the stage. Welcome. So glad to have you.
Thank you. Thank you for having me.
Absolutely.
And 2 doesn't marry a 7 unless 2 has a really great microbiome. So a couple of disclaimers. I'm a CEO of a company called Progenibiome, who's spearheading the microbiome research and Ventura Clinical Trials. I'm going to start with Albert Einstein. If we knew what we were doing, it would not be called research, would it? And I say this because too often, oh, thank you. Okay. Too often in the microbiome, everybody thinks they know what they're talking about, but really we only know about the 1% if we are lucky. This is what I like to show as a pie. The 1% is what we don't know. The 3% is what we don't know we don't know. No, I'm sorry, is what we don't know, and then the rest, the 97%, is what we don't know we don't know. So there's a whole world out there of microbes. And when you start analyzing the microbiome and you start seeing all these microbes, you start saying, what is Doria? What is Rosaburia? What is Eubacterium? What is this bug doing? What is this bug doing to this bug? Are they parasitic? Are they symbiotic? So there's a whole world of microbes that we don't know. However, we can now agree that Hippocrates was right. All disease begins in the gut, and now we have the technology to prove it. William Osler, 1849 to 1919, said one of the first duties of the physician is to educate the masses not to take medicines. William Mayo, the aim of medicine is to prevent disease, to prolong life. The ideal medicine is to eliminate the physician. And I think most of us would agree that we want to fix our patients and we don't necessarily want to keep seeing them in pain. So where have we gone wrong? 4 billion drugs as of 2011, and we're in the trillions right now. What is all that doing to the microbiome? So we've essentially become Drug America. It's not only the drugs that are the pharmaceutical products, but it's also all the nutraceuticals out there. Nutraceuticals that a lot of them are not supervised to know what's in them, right? Is there arsenic in some of those vitamins? We don't know. There's so many products on the market and people are just buying them just because of marketing. And then we have the supersize it, the French fries, the garbage food, the 6 peanut butters at Costco that you end up wearing. And all that, what is all that doing to our microbiome and destroying it? And then what is that doing to our mental health when we have a destroyed microbiome? So content marketing, and I put this slide for people to be really weary about what's going on out there. When you start seeing advertising, when you start hearing things on television, whether it's politicians talking about drugs or celebrities talking about drugs, remember you are being branded. They are selling you something. And whether it's that something that says skinny drugs, if skinny drugs worked, we wouldn't have an obesity crisis in this country and around the world. So unfortunately, we have become the stage for the whole world because we sell our foods, our way of life, our marketing around the world. And unfortunately, with a term we call globalization comes globesity. And you've definitely seen obesity in America, but also around the world. When you look at islands in the Pacific that used to be skinny because they were using, they were hunting and basically fishing, and all of a sudden they're eating chips and Coke, and then obesity starts climbing up in those areas. It's not only obesity. We've seen the highest risk factor for COVID was obesity. So, COVID around the world has become a problem. It's also autism. 1 in 33 kids in New Jersey is autistic. And they're predicting as of 2029 that it might be as high as 1 in 10. So this is a crisis. It's not only autism, it's multiple sclerosis, Parkinson's, Alzheimer's, Lyme disease around the world, and of course, mental health. We have seen an increased rate of mental health around the world. But also, if you look at COVID, mental health since COVID is actually doubled. And it's symptoms of being more irritable, more post-traumatic stress syndrome almost, because now everybody that's coughing, you're worried about COVID. You've got that stress level going. Increased insomnia, increased anger. We're so angry because there's such a division in the world, right? We're divided, etc. And they've managed to divide us to create that marketing, right? So how do we fix all this problem? How do we fix the world? And how do we fix what do we eat, right? So because we are bombarded by a lot of information, and a lot of it is misinformation, a lot of it is really science, right? Science is in a way misinformation, because science changes, science evolves. With new technology, we have new ways of seeing science, and so we have to be more alert onto what's going on and realizing that science, all of science is a hypothesis. We don't really know, things change, right? So an old professor of mine used to say, show me the data, and it's always the data of the day, right? So the microbiome is the new kid on the block that's going to be telling the story. The microbiome is really all the microbes all around the room, on your skin, in your nose, in your eyes. Most people don't realize that when you put a suntan lotion or cream on your hand, it gets absorbed to your blood vessels. Those blood vessels, the microbes that are on that lotion, travel to your gut, to everywhere in your system. So it's all connected. I realized that when I was testing the microbiome of women that were having Botox, and only to find out botulinum toxins in their guts. So the Botox you put in your face ends up in your gut. Now, that doesn't mean that's a bad thing, because it's not that much that we're putting, but the fact is you are putting something in your skin around the eyelids. It goes to the blood vessels, and it travels and ends up in the gut. So it's a very important thing to realize. How do I look at the microbiome? And I always kind of show this slide, because especially for the people that know about cars, the microbiome is like the transmission of your car. It's really what makes you function, and you're going to start seeing that it is your happy place, right? So a transmission of a car, when you break it down, it's 880 pieces. At any point, if a piece of the transmission is broken, your whole transmission is broken. Now, you're going to fix a transmission of a Honda and put it in a Mercedes, it's not going to really work. That microbiome that's in your gut is really comprises of trillions of microbes that are really specific to you. If you change those microbes, it's going to, and destroy them little by little, it's going to be very difficult to find a transmission that resembled you to put you back together. So it's very important to not break and to not continue breaking that transmission in your gut. I've analyzed the microbiome of various areas around the world, because I'm always looking for the lost microbes, because I feel we have, if you look at the African communities, they have 11 phylums of microbes, continents of microbes that share one thing in common. If you look at America, we're lucky if we have 3 or 4 phylums. So we've destroyed a lot of microbes in our guts. So I'm constantly looking for new microbes to just refloralize my own gut. So this is the end of the world, Argentina, fin del mundo. The microbiome has a lot of diversity over there, because it's not really touched, right? Also very diverse in that pond in the middle of Zimbabwe from an elephant. That was very lovely to try to collect. And then it was very different in the Sahara Desert at 120 degrees. There's a lot of E. coli in that sand, and I know because I ended up having it. And then there's very different in Argentina on the iceberg, or in a dome in Singapore, or in a market full of candies. You'll never look at these candies ever again the same, because you'll say, oh my God, there's so many microbes. Think about all the people that are coughing next to those markets, and you're like eating them and taking them home, putting them in your suitcase and incubating those microbes and then eating them. Same thing with the spices. But again, I want you to start thinking that microbes are not a bad thing. Because somebody said, ugh. No, it's a good thing. You're getting microbes. Those spices in the middle of Morocco are, full of microbes, but they're also anti-inflammatory, so this is great. Now, I'm going to say a rhinoceros looks like this because his microbiome is very specific to the rhino, as opposed to the giraffe and the monkey, who have a different microbiome. So every animal has a different microbiome that actually allows them to look the way they are, to be the way they are, and to eat the way they are. Think about an animal that's herbivore, like an elephant, will eat all the grass and the dirt and the seeds and will have ticks in his guts. But an animal like a lion will have no microbes and just blood, because he's a carnivore. So is that behavior of being carnivore, of eating meat, just wanting to be the same because of their microbiome? The microbiome in cows of Virginia is very different than the microbiome of cows of Malaysia. So there's even a difference between the different regions. So how did we get to this? C. diff, as a gastroenterologist, is really what got me to start looking at the microbiome, because C. diff, as we know, has killed a lot of people over the years. And when medications didn't work, fecal transplant was really the way we would fix that. What we discovered in C. diff is that it's not really C. diff as the culprit. The problem is we've killed all the microbiome, leaving C. diff by itself to secrete its toxins. So now you have a bug that's just there with no one around it to suppress it, and therefore it starts trying to kill the host. So it's not really one infection caused by one bacteria, but it's really a domino effect. You kill you have one infection causing a problem, you take an antibiotic, you kill multiple other bugs, and now you're having a domino effect where you're starting to have chronic diseases happening, etc. So it started from that first microbe that we tried to kill. And what we've come to realize in GI is that no microbe just lives alone on an island. And if you kill one, you unfortunately affect many. And when you kill many, you create an imbalance and a dysbiosis. And that is the problem with disease. It's really the loss of microbes and the overgrowth of bad microbes. And I think that's a new concept that people are just starting to understand. What we learned from C. diff is that if you kill with flagyl, vancomycin, fidaxomicin, you keep killing, and you're not really getting rid. Now, you may be getting rid of C. diff, but unfortunately the patient now is chronically ill and is having irritable bowel syndrome, depression. But here's two cases that really got me into this field. Alopecia areata, 2 cases of Colleen Kelly. And basically what happens is she did fecal transplant, they had C. diff, and all of a sudden their hair grew back. These are the cases that got us to see the microbiome, right? My own case that got me into this is really a patient with Alzheimer's that I improved with fecal transplant. His mini-mental status was 21. And then I gave him his wife's microbiome, and I always say this because spouses are my favorite to give, because really you're compatible, right? You pick them out of a crowd because you're compatible to them. So always be nice to your spouse, because you never know when you're going to need their shit. And that's the only time I'm going to say that word. So the guy that was speaking before, marriage is very important, if only for that, okay? So Crohn's disease, Dr. Barodi showed that if you use the crapsule therapy, you go from this to this. So Progenobiome, which is really my genetic sequencing lab, was really created as a research center to understand, without the bias of pharma and academic centers telling me what to do. I said, you know, we need a revolution. We need to understand these microbes better. And we're not here to sell anything. We just are here to kind of understand the research. So the technology that we use is called whole genome sequencing, which is basically by shotgun. So we go deep into the microbiome and we start looking at all the species of the microbes. Our assay is really valid, verified, and reproducible. So in other words, I can test my stools today, tomorrow, and that's how we got data to start understanding the microbiome, is because the stool sample was validated, verified, and reproducible, and normalized. It's very important when you're looking at stools, and I encourage anybody that's like using stool testing labs to test the same stool sample twice. You're going to realize what I realized years ago, which is the reason I opened Progenobiome, that they don't match. And if they don't match, well, you don't really have a good assay that can tell you something. You know, if one day you have Akkermansia that's overgrown, and the next day you've got lactobacillus, you know, that doesn't really help you in treating the patients. So our normals, there's no such thing as a normal in the microbiome space, so we use donors that we've used for fecal transplant, that we've achieved success. In a way to compare, but we also compare within families and also within the location, the region. The one finding that we started when I started this was really to find that we're all different. So, and this is, I'm going to show the picture, is 26 patients. I like to show poop as colorful because, let's face it, there's nothing sexy about poop. So if you look at the microbiome of these 26 patients, you will notice that some of them have like a dark gray zone. That's a simple bacteria that's overgrown in that one patient. But see how the colors are all different in those 26 patients? So it's very difficult to compare two individuals or even 26 patients together, because what you may have Akkermansia, but the guy next door may not have Akkermansia, and Akkermansia could be a bad bug for that person. And I say Akkermansia because that's the new kid on the block, so I have to kind of be responsible as a physician. So we published this, that we're all different, which is not shocking because we all have different fingerprints. Why wouldn't we have different microbiomes? And also we eat different foods. We come from different areas. We were born in different areas. Our parents came from different areas. So all that matters. When you do, even though we are different, our families are very similar. This is my family portrait. The first column is my husband. He's not very happy I show that, but it's okay. Married 30 years. And you could see husband and wife. The second column is me. We're kind of compatible in our colors. We're very similar in a way. And in fact, me and my husband are very similar. But the key thing in this slide is really the difference between the first column and the last column, which is my husband and my little one, are identical in their personalities and in their microbiome. And the two middle one is me and my oldest daughter. We're identical in our microbiome and in our personalities. So I joke with my daughter because she's like, I'm nothing like you, Mom. I go, I beg to differ. I've seen your microbiome. Now, on the whole, we're a neurotypical family, so not too many bugs are just popping out. This is a family with autism. And I demonstrate this because I want to show you the path of the microbiome. So the first column is a mom, and you can see she has an overgrowth of a certain microbe. The next three columns are triplets. The two in the middle are triplets that are neurotypical, and the last column is a triplet that has autism. So you can almost see that the mom probably gave too much of her bad microbe to the kid with autism. So the idea, the concept of fecal transplant using families, using siblings, came from this case because I said, well, if a triplet, maybe I can use triplet number 1 and transplant it to triplet number 3, because we have the technology now to know if they have a good microbiome or not. And sure enough, we did, and the kid is actually improving. So we also discovered what is happening. We all have C. diff. We all have a fingerprint of C. diff in our gut microbiome. So what is happening with C. diff? The first column is a patient with C. diff. What you will notice is their diversity is 1.3. You want to have about a 6 diversity. Shannon index is the diversity score for the microbiome. So when we give fidaxomicin or vancomycin or flagyl, what did we do? We dropped the diversity from 1.3 to 0.8, but we didn't fix the C. diff. Then we gave another antibiotic, and look at what's happening. The diversity went from 0.8 to 0.7. So we keep killing. The last column is showing fecal transplant. What are we doing with fecal transplant? We're giving diversity. We're adding microbes. We're no longer killing. The answer is add, not kill. So what are we learning? What did we learn from C. diff? Diversity is health. Loss of diversity is disease. This is a patient that has chronic UTI. C. diff had psoriasis, and basically had a diversity of 3.8. We gave him a donor that was a happy donor, Shannon diversity of 6.2. Look how he matches the donor. He's completely cured, psoriasis is gone, chronic UTI is gone, but his diversity remains, and he continues to match the donor. On a fun fact, this guy started craving orange juice because the donor was a orange juice addict. So we basically published this bacterial engraftment, which for the first time now we have a stool sample that can predict engraftment. So when you give patients a treatment or you give them probiotics and you want to see if those probiotics are engrafting, if they're going into the colon and staying and doing something, we can actually monitor that. So this is a very important fact. And when people try to sell you a product, whether it's a product of probiotics or even fecal material in a pill, always say, well, what is the engraftment success? Because if they don't continue to engraft, then you've done nothing. So in the world of fecal transplants, really find the bug creating the problem, eradicate the bug, and then restore the microbiome. Autism, this kid came in aggressive, banging his head on the wall. He was seeing a bunch of neurologists and psychiatrists. And he came to my office. He was a 19-year-old, nonverbal. We did fecal transplant. This case took 3 years to get approved by the FDA. Of course, COVID was in the middle of all this. And what we discovered was this kid had an overgrowth of a certain microbe. We gave him the sister. The second column is the sister. And you could see the process of engraftment in this kid, where he is no longer aggressive, no longer banging his head. He's actually saying words. He's communicating with an iPad. The microbe we discovered, Lactobacillus animalis, disappeared. And proteobacteria, he had about 45 or 50% of it. And then it disappeared post-fecal transplant. His good microbes started growing. And on a clinical picture, his CARs improved and his ATEC scores improved. So from that path, we learned a lot because we said, well, there is a gut-brain axis pathway. And obviously, I fixed this kid's aggressiveness with a new microbiome. How do we change it without having to do fecal transplant? How do we understand these microbes better? Well, coronavirus hit, and we decided, my lab switched gears from autism, although we never really switched gears, we just kind of did it all together. Autism one path, Parkinson's. My team gets crazy with me because I go from multiple hurricanes. I have ADHD to the max. But I like to consider this a superpower, so I'll take it. So with coronavirus, I said, well, we have a genetic sequencing lab, and I work with pharma. Surely I can kind of help with figuring out COVID. We were the first lab to identify the whole genome sequence of COVID in the stools, which basically allowed the septic tanks to be tested, because they said, well, if COVID is in the stools if it's in the nose and it's in the stools, let's monitor the septic tanks. One of the things we discovered at the beginning, because we were looking at individuals, not the septic tends to tell you the whole, area, and it will basically show you the genome that is the most abundant. It's not going to give you all the genomes that are present in that septic. When you look at the individuals, you start noticing that there's different variations. One of the things that we noticed was there was different variations at the spike level. We're up to 44 spike mutations. So there's different combinations of spike mutations that we noticed, which at the beginning kind of said, well, how is a vaccine going to work if we have different spike mutations, right? We also discovered that coronavirus stayed in the stools for longer than was predicted. In other words, you could be out of it in the nose in 5 or 8 days and be negative PCR in the nose, but you could actually still have it in your gut for up to 6 months. This case of Tourette's, the little girl was exposed to her parents with COVID. Her parents had COVID at the beginning in March, April. And then in August, she developed Tourette's. She never really had any symptoms of COVID per se. She was one of those asymptomatic. So she was never really treated or anything like that. And then in August, perfectly normal little girl becomes Tourette's and starts spinning and swearing. And so we identified COVID in her stools. We took care of the COVID, and then we stored her gut naturally, not with fecal transplant. And the little girl graduated, and she's now going into nursing school. So it's a beautiful case, again, of gut-brain access. Fix the gut, find the bug, kill the bug, restore the gut, and fix the disease. So if COVID is in the stool, what is it doing to the microbiome? And what does the microbiome look like in COVID patients? So because I have an obsession with families, I decided to look at families altogether. One kid has COVID, the other 3 do not have COVID. What's different in those families? The first column is a kid that had COVID, severe COVID. His parents didn't have COVID, or brother. And the key difference was really the bifidobacteria level. Why bifidobacteria? Because bifidobacteria is a $1 trillion industry of probiotics. So I decided to look at bifidobacteria. But also, remember, I was doing testing stools before the pandemic. So I was looking at newborns and old people and people with cancer. And one of the things that I was noticing was this loss of bifidobacteria in the old people and the cancer patients. So I started focusing on bifidobacteria. And sure enough, with COVID, when we looked at another family, 6 people had COVID, 0 bifidobacteria. And the baby had barely any symptoms, had a lot of bifidobacteria. We then took 72 people that was at the beginning of the pandemic when nobody was really vaccinated. This was before the vaccines. So we looked at all the severe patients, and we looked at moderate to mild, and we looked at asymptomatic, never got COVID, but highly exposed, right? So the physician that's not wearing a mask and exposed to patients with COVID, the politician that's out there in the public and never really got COVID. So we discovered that the people that were exposed to COVID, weren't wearing masks, never got COVID, had a lot of bifidobacteria in their guts, as opposed to the people that were severe that had 0 bifidobacteria. So we published this paper called The Lost Microbes. So it was not only bifidobacteria, it was also a bacteria called Faecalibacterium prausnitzii. And we also discovered that Bacteroides was super high in those patients, and diversity was lost. So that became kind of a signature microbiome to people that were at risk for having COVID. The loss of Faecalibacterium prausnitzii, the loss of bifidobacteria, the high Bacteroides, and the loss of diversity is really your setting, you're in a setup for catching COVID. So what is bifidobacteria other than $1 billion industry? The first column is the mom. The second column is a newborn. A newborn is mostly bifidobacteria. If I don't find bifidobacteria in a newborn that's breastfeeding, there's a problem. Something happened. So this is a picture and a graph of 5 families, or 6 actually. And you'll notice that the high graph is actually the newborn. Newborns have a lot of bifidobacteria. The moms have very little bifidobacteria because they're stressed. They have a newborn baby, and one wonders, is postpartum depression because of loss of bifidobacteria? And should we be focusing on a better way to improve bifidobacteria in these moms to improve their postpartum depression? I say postpartum depression because I did a clinical trial with pharma on it, so I know that it's out there and ignored. And again, you know, mental illness, where we need to start focusing in the moms that are depressed after giving birth, that maybe their bifidobacteria is really low, and we need to start working on that. The process of aging is really loss of bifidobacteria. A little fun fact, degradation of plastic occurs with bifidobacteria. So are we having a problem in the planet because we've decreased our overall bifidobacteria level? Maybe. So bifidobacteria, we noticed, was lost in Lyme disease. It was lost in Crohn's disease. So when you look at Crohn's patients, and you know these Crohn's patients come in, they're angry, they're very depressed. Their bifidobacteria at the beginning, before you even start them on treatment, is very low, it's missing. So if you intercept these patients early and you treat and you focus on their gut health, you may actually avoid them being on biologics the rest of their lives. And then, of course, we decided to look at bifidobacteria with invasive cancer, and notice that loss of bifidobacteria occurred in people with invasive cancer. So the meat of the talk today is mental health. And so we just published actually data that shows a signature microbiome to anxiety. How did this come about was actually from COVID. It turns out that close to 1 million people over the world in 32 countries had severe anxiety during COVID. What was their signature microbiome when that happened is what we discovered, because we started noticing, well, let's start doing a GAD-7, anxiety questionnaire on all these patients. And sure enough, we started correlating anxiety with a microbiome. And it makes sense, right? Because this is, I like to show this picture because this is kind of your microbes in your gut telephoning your brain. So when you think about anxiety and you think about the microbiome, you ask yourself, is it the brain telling the microbes to grow, or is it the microbes secreting their toxins going to the brain, creating the anxiety, right? So which one comes first? Is it the Bacteroides is super high and therefore stimulating some neurotransmitters that are going through the nerve to the brain and starting anxiety pathway? Or is it the fact that it's the other way around? So we decided to look at 119 patients that had anxiety, and we did a GAD questionnaire. This population was was selected to be similar because you don't want to compare apples and oranges. So same kind of region, area, and same kind of comorbidities, BMI, etc. They were kind of very similar. And we noticed that if the GAD questionnaire was really high, their Bacteroides was really high, and their bifidobacteria was really low, basically defining your leaky gut. So when you look closely to patients with anxiety and no anxiety, you will notice that patients with anxiety have a lot less bifidobacteria and actinobacteria, and a lot more Bacteroides. So high Bacteroides is significant for anxiety. Schizophrenia and the microbiome is also interesting. We're coming out with that data yet of species. So we're able to look at the species of the microbiome so we can kind of give that impression. But so far at San Diego, they've kind of showed that there's a difference in biodiversity. So remember, I showed Shannon diversity at the beginning. So there's a difference in diversity from the control group having a lot of diversity and schizophrenics missing diversity. So is schizophrenia a loss of microbes? Bipolar disorder certainly has shown that there is a loss of bifidobacteria, but more important than loss of bifidobacteria is actually a loss of Faecalibacterium prausnitzii. Now, a lot of you probably have a lot of Faecalibacterium prausnitzii, and a lot of you probably treat a lot of bipolar disorders. and you will find that those patients are attracted to you. Are they attracted to you because of what you're saying or because of the microbes that you're carrying in your gut? So there is that's how you're going to have to start. We are just animals, and we're animals essentially sniffing each other for compatibility. That's the way we have to look at it and get over ourselves. We're just a reservoir for microbes, and we're no different than the elephant and the lion and the tigers and all that. So I'm going to kind of finish, although I have a lot of time left. What increases the bifidobacteria? Vitamin C increases the bifidobacteria. Vitamin C is what is put in probiotics to increase the probiotics. So in essence, vitamin C should be increasing in humans, and that's what we discovered, because in the in vitro studies, they noticed that vitamin C proliferates the bifidobacteria. So in humans, if you give people vitamin C, you will notice an increase in bifidobacteria. It is not one that sustains itself, so thus the need to continuously take the vitamin C. But if you think about it, it's a nutrient for microbes and an important nutrient. So we published this. Vitamin C improves gut bifidobacteria in humans. Bovine immunoglobulins. Bovine immunoglobulins comes from the cow. It's the blood of the cow that's spun around, and it's the clear stuff that comes out of the blood. We basically did a study on it and noticed that it actually increases the bifidobacteria and decreases the Bacteroides. So your patients that are very anxious, bovine immunoglobulins, the right bovine, unfortunately a lot of products out there have a lot of, are not really well prepared. So, you know, you may want to switch around products, but if you have a right bovine, you should notice an improvement in anxiety in your patients, mainly because you're decreasing the Bacteroides. Ivermectin, I'm just going to touch very, controversial little drug there. Ivermectin is a product of a bacteria called Streptomyces, which is in the same phylum as Bifidobacteria. So ivermectin, that substance, actually stimulates bifidobacteria and increases bifidobacteria. The problem is it doesn't sustain, it's only short term, so you use it when you need it. This is why probably it works as an antiparasitic, because it actually stimulates the good bugs to get rid of the bad bugs. So ivermectin, that's what we noticed with the bifidobacteria. Probiotics, a lot of people, say, well, we're losing bifidobacteria. Why don't we just take probiotics? A couple problems with probiotics. Is the label real? 16 out of 17 probiotics out there on the market are actually not real. They don't even have bifidobacteria. So 1 out of 17 only has it. Then the other thing is the bacteria, by the time it got to the store, is it alive or dead? Remember, you're reproducing your microbiome, which is alive and which is anaerobic. It doesn't breathe oxygen, right? So now you're giving it a bacteria that stayed over the counter in the pharmacy, God knows for how long, 6 months. Maybe they had a temperature, they had a power out, and the temperature wasn't monitored properly, and therefore the bacteria is dead. So now you're taking this pill that actually 1 out of 17 has bifidobacteria, but it's dead. So what is that dead microbiome, those dead microbes doing to your live gut, right? I mean, it's like living with a bunch of corpse, right? So that's how you have to start thinking about the probiotics. And then the other question that I had, because I've started testing a lot of people that take probiotics, is giving a probiotic stopping my ability to make my own probiotics, right? When you take pancreatic enzyme, you're essentially shutting down your pancreas from stimulating enzymes, right? Because your pancreas is saying, well, she's going to give me enzymes, why do I need to produce it, right? Are we doing the same thing with the colon, where we're basically giving it microbes? Why do we need to build what we already have in our guts or nourish? And then the last thing about probiotics is, do they implant? Do they engraft? when I take a probiotic, is it going in my colon and is it starting to implant and grow new microbes on their own? Or do I have to take these probiotics for the rest of my life, right? And then depend on the company that's giving me these probiotics and depend on the pharmacy to keep them at a perfectly temperature so that they're alive, right? So in essence, we are dependent on this whole world of probiotics. Maybe the answer might be better to just know how to grow those microbes in our guts ourselves, right? So we published a paper called The Impact of Probiotics on the Gut Microbiome, where we decided to look at people that were just a random study, where we looked at people that were taking low-quality probiotics versus high quality, and by high quality I mean the refrigerated type, the ones who've done clinical trials, the ones who've published. And we noticed that the ones who've published, who've done clinical trials, had a lot higher bifidobacteria in their colons than the ones who were taking probiotics over the counter. And essentially, that brought on the fact that the importance of what you're putting in your body as far as the right probiotics. The next thing that happened, and this was kind of my experience during the pandemic, I kept killing my I killed my bifidobacteria accidentally. I didn't do it on purpose, but I kept drinking kefir, thinking, well, I killed my bifidobacteria. The beauty of having a genetic sequencing lab is you get to test your microbiome on a regular basis, and you know when you're going to have a cold because you know your bifidobacteria is low. So you're like, ooh, I better start taking care of myself and doing yoga and meditation and everything and decrease stress. But one of the things I did is I started taking kefir, and I started drinking a lot of kefir. And I'm noticing my bifidobacteria is not going up, and yet I'm drinking like a gallon of kefir a day. So I decided to test my kefir, only to find out that my kefir didn't have bifidobacteria, even though it said in the back of it, bifidobacteria. So then I said to myself, well, here I am telling my patients to drink kefir and they're not getting better. Well, if I'm not getting better, how are they going to get better, right? So I decided to go to my grocery store in Malibu, and I said, I'm going to test all these products. One of them was $27 probiotic drink, and I bought it. And I said, well, it's $27, got to have, because the higher price, that means it's really good, right? And lo and behold, it didn't have bifidobacteria in there. So it was a $27 crap. Only 3 products had bifidobacteria, and which was very surprising out of 26. This paper got an award at the American College of Gastro. You would think the FDA would be on it to kind of say, hey, maybe we should start testing the microbiome. So that's pretty much, as far as treatments, that's all we know right now. There's a lot of products that we're testing to see if the bifidobacteria, there's a great product that I'm working with, a company out of Switzerland right now, that seems to be very promising in bifidobacteria increase, especially we're going to be starting to use it in invasive cancer. I can't really talk much about it. The future mental health seems promising because now we have a marker. We actually can say, hey, we got to focus on the microbiome. Now, it may not be just the microbiome, obviously, because the whole body is connected, right? It's the hormones, it's the brain, it's the neuro, it's everything together. But we cannot forget the gut, because that's your motherboard, right? So this is the case that I showed you of psoriasis at the beginning with engraftment. It was actually a suicidal patient. And after fecal transplant, the patient was no longer suicidal. This is a breakthrough, and this needs to be done. Unfortunately, we are dealing with FDA and regulatory, and it took 3 years to approve 1 kid with autism. We're trying to get 30 kids approved, and it's been 4 years, and I swear I'm going to start picketing in front of the FDA with all the moms. Please allow our protocols. This is medicine. We should be allowed, especially if there's an informed consent between the moms and the kids and the doctor, we should be allowed to do this. This is not right. So I think I showed that all disease begins in the gut with all those colorful pictures. But first, do no harm. That's very important. I'm going to leave you with Albert Einstein, because I started with Albert Einstein. He used to say, if the bee disappeared off the face of the earth, men would only have 4 years to live. What is the bee? So the bee eats water, sugar, and depends on vitamin D from the sun. If you look at the rectum of the bee, the microbiome of the bee is really the honey, right? If you look at the rectum, it's bifidobacteria and lactobacillus. So what Albert Einstein meant to say is if the BIF disappeared off the face of the earth, men would only have 4 years to live. And this is a crisis, and what gets me on stage and coming and speaking and being out there is we analyzed over 1,000 samples of Progenobiome in the last 6 months. Less than 5% had bifidobacteria, and 1 patient had lactobacillus. 1. This is a crisis. We're losing microbes. We're eventually not going to be able to find them. We're having a hard time finding good donors as it is. So my platform is Save the BIF, and I hope you remember it as well and push this motion of saving the microbiome. So the microbiome, what we know so far, it is promising, but we're still at the beginning. It's all research. I wrote this book because everybody was going to say I was full of it, but I said, let's talk about it. And then we wrote a better book. Dr. Jordan and I were doing the Regenesis project for neurological problems, and I'm also working with Dr. Bistritsky for anxiety disorders. We're fixing the brain and the gut to fix anxiety. This is me in a nutshell, and I'm open to questions since I have time. Thank you.
Do we have any questions? Start right over here.
I have two, well, I have a ton, but the two I was curious about is, have you done any studies on blue zones around the world? You know,
Yes, we have that data. It's coming.
Okay, and then also, I know friends, and I'll admit myself, that have done colon hydrotherapy. I don't do it regularly. I've tried it, but I just don't know if it's the healthiest thing to do.
You know, there's not enough data. There's actually no data on it. Hypothetically, I would think that you're killing the gut microbes, so I would, or maybe you're refreshing it. I don't know. But I would say, you know, just probably avoid it, especially if you're healthy. Don't kill what you have. Yes.
Thank you for a wonderful talk. I'm a current child and adolescent psychiatrist, so I deal primarily with teenagers and younger children. I guess based on your research, and especially given FDA is even more concerned about children and adolescents, given the state of the research, what would you recommend? Is it more maybe for even younger people, just dietary changes? And I know I've heard a lot of, as opposed to probiotics, prebiotics, so I don't know if that's something you can discuss or address also.
Yeah, so definitely prebiotics. So because we are limited, right, with autism right now, we're limited. I'm trying to figure out what feeds these microbes so that I don't need to depend on changing the whole microbiome and just supplement and work with nutrition. I really think down the road it's going to be a nutrition solution in a way. The amino acids that they need, that they lack, and the vitamins and the bovine. So it's really all nutrition in my opinion.
Thank you.
But I have a protocol that I'm starting to work with Dr. Bistritsky. So if you want to join, all the doctors that are here, join the Biome Squad, it's called. PM me, you know, my email is up here. Please reach out to me because we work together. If you have something that you've done that's working amazing for your population, then test the microbiome before and after, because essentially it'll tell you whether you're doing good or not, you know, and what you're changing, you know. So that's it.
Thank you so much for a wonderful lecture. I had two questions. First of all, could you tell us, out of curiosity, the name of the 3 brands that you discovered that actually contained the 3 products that you had mentioned? And then secondly, I was curious.
If you turn off that camera and you keep it top secret.
Yes, we promise.
So turn off the camera. Is it turned off? Oh, is it turned off? Yeah, no, I mean like no videotaping. Because every company comes to me and they're like, we'll pay you $50,000 to be the spokesperson for this probiotic, right? And I'm like, well, show me what it's doing. Let's see the data before and after. You don't even have to pay me to say which probiotic, because I'm not paid by those products that I've mentioned. I will say it because that's the right thing to do. But the thing is, nobody's volunteered. Nobody's come to me and say, oh, you know what, Dr. Hazan, we believe so much in our product, we want you to test it on patients. So that's what concerns me, because I've reached out to a lot of companies out there in the probiotic world. And I've said, let's test your product. I mean, you're saying it's good bifidobacteria and it helps patients and digestive is improving. Well, let's see the data. I mean, my lab is here for an unbiased opinion, because I want to know the truth myself. You know, I have to take that yogurt, I have to drink that product, I have to take that vitamin. So I have to make sure that I'm safe myself. Why would I want to alter that data, right? So I think it's important to have unbiased research.
Thank you. And one other brief question. Could you briefly explain the process procedurally that a fecal transplant entails? What does that look like for a patient or for a child?
So it's testing the stools of a donor to make sure that they're clean, so that they don't have vancomycin-resistant E. coli. There's a whole bunch of tests that we do on the donor, blood work and stool test. And then essentially the kid comes in to the colonoscopy. I do them via colonoscopy. I like to reach the cecum. The cecum to me is the motherboard. It's where the contraction of the colon go the opposite way to kind of store. If you think about what the appendix is the original storage of the bifidobacteria. So I try to go over there to kind of implant. In there, I also clean the biofilm, do a colonoscopy, and then I take my stools from my donor fresh. They donate it in a container. And then we process them in a liquid form, essentially, and then we plant them in the cecum, put the patient upside down for 20 minutes, and then that's it. Let them grow the microbes. And then we, of course, put them on a diet and all sorts of things, because you don't want to give, you know, a new microbiome and then they go back to eating something that has like arsenic in it, for example. So I try to control as best as possible the nutrition and the stress level of that person. I have a lot of people that are like high-powered executives that come to me for fecal transplant, and I actually refuse to do them because they go back to their bad lifestyle and then they're killing what I just gave. So what's the point, right? So I'm very, selective of what I do and how I do it.
All right, we have time for one more question. I think we had right over here.
Thank you so much. I really enjoyed your talk. Quick question, and it may be that the research isn't there or you're doing it, but right now it looks like a lot of it's on the quantities of the different bacteria in the gut. And I'm curious if there's, you're looking at functionality of them or interplay functionality and what that looks like.
So right now I'm looking at imbalance, right? And for what I know so far of what's an imbalanced microbiome, I'm looking at interactions between the microbes, and I'm looking at functionality by looking at reproducibility of the microbe. So in other words, we do two pipelines on our patients. We do, one is a DNA pipeline, which we call the floor test, which is essentially a DNA of all the microbes that are seen in the gut, but those could be alive or dead. Then we do what's called a messenger RNA pipeline, which basically looks at reproducibility of the microbes. So that's it's more expensive, it's more time consuming, it's a 3-month process, but it tells me whether that microbe is alive. And if that's alive, then I have to worry about it. And then from there, we look at the metabolites, which is important. But so many metabolites are not defined yet, and there's so many microbes. Like I said, so many microbes, we have no idea what they're doing, if they're good bugs or bad bugs. And even when you look at a bug like E. coli, Could be a good bug for some people, could be a bad bug for others. It could be good up to a certain level, and it could be bad up to a certain level. So I think that's really the problem with the microbiome space right now is when do you say it's good to have this much E. coli and it's bad to have this much E. coli or other bugs. All right.
All right. Thank you.
Well, thank you so much.
Thank you, Dr. Hazan.
Thank you.
Wonderful presentation.